Assalamualaikum and hi everyone. Jadi sesi kali ini kita akan lihat presentation para pelajar yang akan berkongsi ilmu bersama kawan-kawan bagi persediaan menghadapi final exam yang bakal tiba dalam sesi Dari Kita Untuk Kita. Jom kita tengok.
Hello, Assalamualaikum. My name is Kamal and I'm from S1 5 to 11. So now I'm going to present to you guys about mechanical wave and sound. So what will you learn in the video today are how to define wavelength and how to solve problems related to equation of progressive wave. So let's start with types of wave. Waves have two types, which is progressive wave and stationary wave. And then progressive wave is divided into two, which is transverse wave and longitudinal wave. Okay. Progressive wave is the wave that propagated continuously upward from the source of disturbance. Transverse wave is wave which the direction of vibration of particles is perpendicular to the direction of wave propagation, while longitudinal wave is a wave which the direction of vibration of particles is parallel to the direction of wave propagation. So this is how the motion of the wave. Transverse wave perpendicular, transverse wave perpendicular, and longitudinal wave is parallel. Right, so let's know the terms that we will use in this topic. The first is wavelength, or also known as lambda. So wavelength is the distance between two consecutive points with extreme phase in the wave, and the unit of lambda is meter. So where is the wavelength? Wavelength is found from the initial position to the one complete cycle. Here is also known as wavelength, and or from peak to peak, also known as wavelength, or from trough to trough, also known as wavelength. So next, wave number, or we call it as wave. So there is a number of waves in a unit distance, and the unit is in radian per meter. And then amplitude. Amplitude is maximum displacement from the equilibrium. Amplitude is maximum displacement from the equilibrium position. Okay, so from the initial position or equilibrium, y is equal to 0 until y is equal to the maximum. Next, frequency. Frequency is the number of cycles produced in 1 second. And the unit of frequency is hertz. This frequency, you can find it from the formula later I show you. And period. Period is the time taken for particles to complete 1 cycle. Next, okay, this is all the formula that we will use in this topic. So the general formula is, the general equation is y is defined, and this is the formula for speed, this is formula for velocity particles, and this is formula for acceleration. The velocity particles and the speed of the wave is different, okay, remember that. And then this is the formula that we will use to find frequency, and this is the acceleration, maximum acceleration, and this is omega. Omega, you can find it if the question asks you. Okay, now, so let's try to do some examples. So example 1. Figure 2a shows a graph of displacement against time, and figure 2b shows a graph of displacement y against distance of the progressive wave. So from the graph, we use angular velocity, wave number, wave propagation velocity, and the displacement equation of the progressive wave. Okay, so from this graph, you guys can see dibagi graf y against t, di mana kita boleh guna graf ni untuk cari dia punya period, and dibagi graf y against x ni kita boleh guna untuk cari dia punya lambda. Okay, so for question 1, kita nak cari angular velocity kan. So kita kena tahu that angular velocity adalah omega. Omega dengan formula adalah equals to 2 pi over t. Okay, so sekarang ni kita tak tahu t kita berapa kan. So bila kita tak tahu t kita berapa, kita kena cari So from here, kita boleh tahu yang ni one complete oscillation ni, itu adalah satu period. Itu istilah kan. And then, dia bagi maklumat lagi sampai ni sama dengan 6. So yang ni, from here to here, berapa? So, that this is 1 period and half. Okay, so that's why I write like 1.5 is equals to 1/2 lah. 1/2 T is equals to 6 and then T is equals to 4 seconds. And then I substitute T into this formula, so I get 1.57 radian per second. Okay. So, yang kedua, soalan dia ditanya, calculate the wave number. So, wave number formula dia adalah K equals to 2 over lambda. So, macam mana kita nak cari lambda? Kita kena guna graf yang dua bini. Kenapa tak boleh guna yang ni? Sebab yang ni dia dah bagi ini adalah time. So, kita guna je yang ni. So, formula samalah kan. Ini adalah satu lambda. Satu lambda, and ni adalah 2 lambda. So, bila 2 lambda, yang ni 7.5 ni akan jadi half lambda. So, kita buat half lambda 1.5, 1.2, lambda is equal to 7.5 cm. So, lambda akan jadi 5 cm. So, disebabkan ni adalah cm, so saya tukar dia kepada meter. So, dia akan jadi lambda equal to 5 times 10 to the power of negative 2 meter. So, substitute lambda ni dalam equation 2, and then you will get 1 to 5.66 radian per meter. Okay, alright. So, next, so the question asks us to find wave velocity, right? So, wave velocity, the formula is V equals to F lambda. So, this. How to find F? So, F, you can find it from the formula F equals to 1 over T. From here, I got it from here. So, I substitute into T, and then I got F is equal to 0.25 Hz. This is actually 0, so not 1. So, this frequency and lambda that I got, I substitute, then I get V is equal to 1.25 times 10 to the power of negative 2 meter per second. Kalau yang B, dia tanya bagi general equation ni kan. So, general equation kita kena ingat. Dia punya general equation macam ni. Y kurungan X, T, tutup kurungan is equal to A sin omega T plus or minus Tx. Okay. So, this is the general equation. Ini just substitute je maklumat yang kita dah dapat, yang kita dah kira tadi tu dalam equation ni. So, buat macam ni, Y dalam kurungan X, T, tutup kurungan equal to 0.02 is kita dapat daripada dia punya graph yang ni. Amplitude is maximum displacement, right? So, this is the maximum displacement 2.0 cm. So, we change it to meter. Kita akan dapat 0.2. And then, we tulis sin. So, omega kita dapat tadi. Omega is equal to 1.57. Kita tulis kat sini. And T kita akan dia. And then plus K. K kita dah dapat 1.25.66 radian per meter kan. Kita just masukkan je and then add. Untuk kurungan. Okay, kenapa dekat sini positif? Sebab, kita tengok balik. Graf ni, dia start daripada 0 to positif kan. Positif sebab 2.0. So, dia akan jadi positif dekat sini. Yang positif atau negatif ni, dia akan memainkan peranan. Kita tengok pada graf. Kalau graf tu dia start bawah, macam dia punya ni, dia start di bawah sini, and naik atas sini, itu kita punya kita punya sign dekat sini akan jadi negatif. Sebab kita punya amplitude, kalau graf kat bawah ni, akan jadi negatif. Tapi in this case, dia adalah positif kan, so dia kena positif kat sini. Alright. Jangan stop dekat sini je. Kita kena continue tulis dia punya unit. Kita kena tulis where Y and X are in meter and T is in second. Ini wajib kalau tak tulis potong-potong. Okay, so let's continue to the other example. So example 2. A progressive wave equation is given by Y is equal to 5 times 50 pi K minus 2x. So where X and Y is in meter and T is in second. So determine the wave's velocity, determine the wave velocity, and then the particle's velocity at X equals to 2 meter and T is equal to 1 second. And the next, the acceleration of the particles at X equals to 2 meter and T equals to 1 1 second. And the final, calculate the maximum acceleration of the particles. So how to solve it? So first, it's given that in the question, this is omega and this is p. We compare with the general equation. So let's start with omega equals to 2 pi f. Why I use 2 pi f instead of 2 pi over 2? Because I want to find frequency. So directly, omega is also equals to 2 pi f. So I just use this formula and then I calculate macam biasa. So I get 25 hertz. The next, t. The given t is 2. So the formula of t is t equals to 2 pi over lambda. So from this equation, kita boleh cari lambda equals to pi meter. Ataupun kita boleh tulis je pi tu dalam decimal point pun boleh. So just substitute v equals, just substitute yang ni kita dah dapat tadi tu ke dalam formula yang ni. So kita akan dapat velocity is equal to 78.54 ms per point. The one. So question number 2 is the particle's velocity. Find the particle's velocity at x equals to 2 and t equals to 1 second. So velocity particles, kita punya formula apa? Kita kena ingat benda tu. So kita punya formula adalah dy equals to a omega cos omega t minus 2x. Okay, so itu sebenarnya lebih kurang sama je dengan kita punya general equation. Cuma dia ada t tambah w kat sini dengan cos. Kita substitute je apa yang ada dekat equation yang general ni. So kita substitute je semua maklumat yang kita dah ada dalam ni. Dan omega ni kita tahu 50 pi. And then cos omega lagi 50 pi lagi kita buka kat sini. And then t is equals to 1 je kan. So kita substitute 1. And then t adalah 2. And substitute x sama dengan 2. So kita tekan calculator. Make sure calculator in gradient mode. So bila kita calculator kita akan dapat jawapan negative 513.27 ms per point. Iaitu dia punya velocity particles. Okay, lepas tu soalan yang ketiga, ditanya the acceleration of particles at x equals to 2 and t equals to 1. Okay, so formula acceleration particles ni saya dah tunjuk tadi dekat awal-awal slide tadi tu. So kita punya formula adalah a equals to amplitude a omega squared sin omega t minus km. So sama je, kita substitute the information dalam ni. Nanti kita akan dapat 93.37 darab 10 kali negatif 10 kali 3 ms negatif 2. Tapi kita letak negatif sebab apa? Sebab the wave moves to the right. When the wave moves to the left, so dia punya acceleration kepada itulah. Tapi ni sebab dia move to the right, so dia akan jadi negatif. Right. So soalan yang keempat adalah maximum acceleration of the particle. So maximum acceleration kita guna je formula general, iaitu a is equals to negative omega squared a. So a dia kat sini dia kita guna kenapa kat sini kita guna a? Sebab dia kata maximum kan. Soalan tanya maximum acceleration, so kita guna a. Kalau soalan tanya find the acceleration at y equals to berapa, so barulah kita guna a equals to negative omega squared y. So kita akan dapat a is equals to negative 123.27 times 10 to the power of 3 and plus negative 2. So that's all from me. I hope my video will benefit you guys in doing revision for PSPM. And let's aim for 4 flats in PSPM. You guys can do it. I mean, you can do it. Don't give up. And we will celebrate our success soon. Good luck everyone. Thank you.
Bismillahirrahmanirrahim. Hi and Assalamualaikum everyone. My name is Nurhaida binti Bukhari from S15P11. Today I would like to discuss about particle vibrational velocity and wave propagation velocity. What is particle vibrational velocity? Particle velocity is the velocity of a particle, real or imagined, in a medium as it transmits a wave. The SI unit of particle velocity is the meter per second, which is ms power of -1. Alright, particle vibrational velocity Vy in a wave. What's the formula? Okay, take the derivative of the wave function with respect to t, keeping x constant. How do we get that? Alright, we derive the a sine times omega t plus minus kx. So we get a omega cos times omega t plus minus kx. Remember, particle velocity is not the same as wave velocity. Particle velocity is not constant and varies with time t. As you all can see in this picture, a transverse wave on spring is moving to the right with a constant speed velocity wave. The speed of the particles changes from time to time as the wave passes. Alright, let's move on from particle vibrational velocity. What is wave propagation velocity? Alright, wave propagation velocity is defined as the distance traveled by a wave profile per unit time. From the picture on the left, it moves a distance of wavelength in time. The SI unit of wave speed is ms to the power of -1. The value of wave speed is constant. The picture on the right is how we get the wave propagation velocity, which is v equals to wavelength times frequency. Okay, now let's move on to the exercise. Example 1. A wave has frequency of 50 Hz and a wavelength of 10 meters. What is the speed of the wave? Okay, yang diberi adalah wavelength dan frekuensi, dan yang perlu dicari adalah speed, which velocity. So dengan menggunakan rumus V equals to wavelength times frequency, kita masukkan nilai wavelength adalah 10 dan nilai frekuensi adalah 50. So kita akan dapat speed dia 500 ms per ms -1. Example 2. A sinusoidal wave travelling in positive x direction has an amplitude of 20 cm, a wavelength of 50 cm, and a frequency of 8 Hz. Find the wave number, period, angular frequency, and speed of the wave. Okay, yang diberi adalah amplitude, wavelength dan juga frequency. So, untuk mencari wave number, kita guna rumus K equals to 2 pi divide by free wavelength. So, kita masukkan nilai, dapat 2 pi bahagi dengan 0.5 sama dengan 12.57 rad per meter. Yang kedua, kita cari period T. Dengan menggunakan rumus T equals to 1 per frequency, kita masukkan nilai frekuensi, dapat 1/8 sama dengan 0.125 second. Yang ketiga, kita nak cari angular frequency, which is omega. Dengan menggunakan rumus omega sama dengan 2 pi f, kita masukkan rumus f, dapat jawapan 50.27 rad per second. Dan akhir sekali kita nak cari speed v. Dengan menggunakan rumus v equals to wavelength times frequency, kita masukkan nilai wavelength dan frequency, 0.5 darab 8, kita akan dapat 4 meter per second. Last example, which is example 3. Okay. A. What is meant by wave propagation velocity? The answer, the distance traveled by a wave profile per unit time. B. A progressive wave is given by the equation y equals to 0.4x sine times 600t minus 5x. Okay. Determine the direction of the wave propagation. The answer is to the right. Second, determine the wave propagation velocity. Okay. The formula for wave propagation velocity is v equals to wavelength times frequency. Macam mana kita nak cari wave propagation velocity bila frekuensi dan juga wavelengthnya tak diberi? So, kita kena cari satu-satu. Macam mana nak cari wavelength? Kita guna K equals to 2 pi per wavelength. Kita masukkan nilai K iaitu 5. Dan kita kira macam biasa. So nanti kita akan dapat wavelengthnya 3.14 meter. Kemudian kita nak cari frekuensi pula. Kita guna rumus omega equals to 2 pi f. Kita masukkan nilai omega 600. Dan kita kira macam biasa. Akan dapat 95.49 second negatif 1 for frequency. So dah dapat nilai frekuensi dan juga nilai wavelength. Kita boleh kira wave propagation velocity. Kita guna rumus V equals to wavelength times frequency. Kita masukkan nilai wavelength 3.14 meter dan kita masukkan nilai frekuensi 95.49. Kita darabkan dan kita akan dapat speednya. Sorry, bukan speed, the wave propagation velocity, iaitu 299.84 ms power of negative 1. Thank you.
Assalamualaikum and hello everyone. Now we in chapter 10, mechanical wave and sound, and we have subtopics: displacement, graph of the wave, and here is the graph of displacement against time. So we can see here displacement as the y-axis and time as the x-axis. So here we have amplitude, period, phase and trough. So here we know that amplitude is defined as the maximum displacement from the equilibrium position to the crest or to the trough of the move motion. Okay, so here we also have period. Period is defined as the time taken for a particle in the wave to complete one cycle. So here we have one cycle, and here we have another one cycle. So here we have one period, trough to the trough, and we can also have one period here, crest to the crest. Okay, now we consider the equation of the wave is y equal to a sine omega t minus kx. So here a means amplitude. Sine is the graph of sine graph, and omega is angular frequency, which is omega equal to 2 pi over t, and negative is mean comes from the left, so it's mean to the right. So this graph is show the displacement of any one particle in the wave at any particular time from the origin. So for example, we when x equal to 0, so here we have y equal to a sine omega t minus kx. So x will be 0. So we'll place x to 0. So we get y equal to a sine omega t. So here we have amplitude. Amplitude we can change to the value. For example 2, and it will be here negative 2. So here we know that a here means amplitude. So if we get the value here is 2, so we can replace it with 2 here. So here we have 2 cycle. It means here one cycle is mean 1 period, 1 t, and here is another cycle is 2t. So here we have 1 period, phase to phase, and here we have half of the 1 period and 1 over 2t, and here we have 1 and half of the 1 and half period, 3 over 2t. So displacement, and the unit is always cms, and the time is the unit is the period. This unit is second. From me, thank you.
Assalamualaikum and hi everyone. Today we are going to discuss 10.1d, graph of displacement against distance, y-x. The graph shows the displacement of all particles in the wave at any particular time t. For an example, consider the equation of the wave is y is equal to a sin omega t minus kx. At time is equal to 0, thus y is equal to a sin omega 0 minus kx. And the final answer is y is equal to negative a sin kx. Next, this is a graph of displacement against distance, y-x graph. This is the amplitude. This is the wavelength, and wavelength. Next, question 1. Determine the amplitude and wavelength. As we can see here, the amplitude is 2 meter and the wavelength here is 2 meter. And the answer A is equal to 2 meter and wavelength is equal to 2 meter too. Next, question 2. A transverse wave on a string travels at 20 meter per second. A graph of the height of the wave along the x direction at a certain moment is shown below. As we can see here, the wavelength is 4 meter. Kita akan cari F dan kita gantikan V sama dengan F lambda. V per lambda kita gantikan 20 per 4 dan kita akan dapat 5 Hz. Seterusnya, question 3. Figure shows a displacement y against distance x, graph of the time t, for the progressive wave which propagates to the right with a speed of 50 cm per second. Dalam soalan ada bagi, given v sama dengan 0.5 meter per second dan wavelength adalah 1 cm. Tapi kita tukar kepada meter dan kita dapat 1.0 darab 10 kuasa negatif 2. A. Determine the wave number and frequency of the wave. Jadi kita buat K sama dengan 2 pi per lambda. K sama dengan 2 pi bahagi dengan 1.0 exponent 10 negatif 2. Kita akan dapat K sama dengan 200 pi per meter. Untuk frekuensi pula, kita guna formula V sama dengan F lambda. Kita substitute dan kita akan dapat F sama dengan 50 Hz. B. Write the expression of displacement as a function of x and t for the wave above. B. Y x t is equal to a sin omega t minus kx. Kita substitute semua dalam ni dan kita akan dapat y x t is equal to 0.03 sin 100 pi t minus 200 pi x. That's all from me. Thank you and bye-bye.